Metro Ninjas. Welcome to another enthralling and exciting day of geometry. Today is awesome because we get to talk about one of the greatest pieces of geometry, and that is trigonometry. So trigonometry is going to be huge as you advance into higher mathematics. So understanding what it means for sine, cosine, and tangent, those weird buttons that are at the top of your calculator, understanding what those are going to be very helpful. So now what we're going to do is we're going to talk about trig ratios first. And a ratio, like we've talked about with similar triangles, like we talked about when we were doing special right triangles, is simply a ratio or a comparison of the lengths of the side of a right triangle. So just like the Pythagorean theorem, for trigonometry, and for these ratios we're going to talk about today, they need to be in a right triangle. Now, as you advance further in mathematics, you'll get into how to solve without a right triangle using the law of sines or the law of cosines. But for the sake of today, we're going to focus on our three basic trig functions, that is sine, cosine, and tangent. So on your calculators, you can see the sine, cosine, and tangent function. It's not sin, cos, and tan, okay? But sine, cosine, and tangent. These are the three functions we're going to be focusing on. What I need you to do first is we're going to go to mode. Okay? Under mode, you see all these settings. This is probably where your calculator is, because that's what your standard calculator functions are. And we're going to go down here to where radian is. And instead of being in radian mode, which is in terms of pi, when you're thinking about your unit circle, you guys will learn about that a lot more in trig, we're going to hit the right arrow and press enter on degree mode. Okay, so for the remainder of this geometry, even in algebra 2, it's not going to mess you up. Not till you get into trigonometry, where you need to worry about radian mode. Is radian mode even going to affect you? But your future math teachers will make sure you're in the right mode as well. After you're in that mode, we're good to go. So let's focus on finding the ratio, okay? So there is a handy dandy mnemonic device that helps us remember how to find the ratio. So our first ratio is sine, okay? So the mnemonic device is simply this: so, ka, toa. Okay. So, ka, toa. You might remember that teacher that went viral a couple years ago. She was going crazy, bouncing around on desks. This is what she was talking about. She wasn't just screaming to scream. She was talking about SOHCAHTOA, and she was trying to reinforce it to her students. Okay. So in SOHCAHTOA, the S stands for sine. The C stands for cosine. And the T stands for tangent. The other letters are all the comparison of the sides, okay? So sine is O over H. It's the opposite side over the hypotenuse. Cosine is A over H, the adjacent side over the hypotenuse. And then now I'm sure you can figure out what tangent is, being O over A. Okay, tangent is opposite over adjacent. So what happens is if you're looking at a right triangle, before we go in and start talking about sine, so if we're looking at a right triangle, okay, I know it's a right triangle because it's got a right angle. Just like we talked about with the Pythagorean theorem, across from our right angle is always going to be our hypotenuse. Always across from the right angle. Now, the opposite and adjacent may change based on the angle we're talking about. So I'm going to put an angle in here. I'm just going to let it be angle X down here at the bottom. Okay. That angle is in this bottom corner, this bottom vertex. Oops, wrong button. So now, in relation to this angle, the side that's across from it, the side that it's not touching, is the opposite side. Okay? And the side that it is touching, that's not the hypotenuse, is our adjacent side. That is what trig really boils down to. Identifying our angle, and then based on the angle, we're going to first identify hypotenuse, adjacent, and opposite. So just like we did with 30, 60, 90s, we identified the short leg first. The short leg was across from the 30. We then went and switched and we identified the long leg across from the 60. And like every other right triangle we've been doing, the hypotenuse is always opposite the 90 because the hypotenuse is our largest side, and our largest side is always opposite our largest angle. So the sine ratio is opposite angle, opposite leg over hypotenuse. So looking at this, it says find the sine of angle A. So you'll see your trig function here first. Okay, so that's our trig function. And what comes directly after it is the angle that they're talking about. Okay, so they says find the sine of A. So I'm going to go ahead and put my little X down here so we know for sure what we're talking about. So angle A is that bottom right vertex. Let's identify the hypotenuse first because that's the easiest one. The hypotenuse never moves. The hypotenuse is always, always, always opposite that right angle. And then now for the side that is opposite of our given angle, so opposite of X is 5. Okay, so that's across, that's opposite. And then adjacent is going to be the side that X is touching. So if you think of it by who's sitting next to you, so the person that is sitting next to you is considered adjacent. You can touch them. Angle A is touching its adjacent side. But if you look across the classroom or you look to the person in front of you, that is considered opposite. You cannot touch them. Okay. So if we want to focus on what we can and can't touch, that's another way that some students find to be successful. So we're going the sine of A. So we're going to look at our handy dandy trig function. So S-O-H, okay? Not Ohio State, sorry guys. Okay, so we're going sine of A equals the opposite side over the hypotenuse. So now we're just going to substitute our given value. So sine of A is 5, which is our opposite, over 13, our hypotenuse. Now, if you find yourself doing sine and cosine are a lot like our percentages. They should never be more than 1. And that's because the unit circle, the greatest value on our unit circle, is 1. So sine and cosine should never be more than 1. Tangent can be if the numbers line up that way. Find the sine of S. So angle S is the one we're focused on. So I'm going to go ahead and put this right here in the corner. We will never ask you to find the sine of M because it's not going to work. Okay, that's our 90-degree angle. Sine is going to help us over here. Across from there is our hypotenuse. Always, 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 the 90 is across from the hypotenuse. Okay. Across from the angle given is S. That is our opposite side. And then adjacent is the one that it's next to, the one that it's touching. Okay. Adjacent. Hypotenuse first, then go to opposite. If you want to go adjacent, because you know, hey, it's touching the hypotenuse for sure, it's touching the adjacent for sure, then I can just finish with the opposite because it's not touching it. Okay. So sine of S, sine is SOH, S-O-H, okay, which is sine of S is the opposite side over the hypotenuse. Looking at our problem, it is 12 over, we don't know that. We're missing a side. What theorem, so I get this guy out of here a little bit, a little scooch, 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 mess up my calculator. What theorem allows us to find the missing sides if we know 2 out of 3? Yeah, Pythagorean theorem. So we got to go Pythagorean theorem to help us find that side first. Okay. So 9 squared plus 12 squared is c squared. 81 plus 144. 225 is c squared. And then we just square root both sides to get rid of that square. So we find the hypotenuse to be 15. So I can stay on color brand here. So 15. Now we can come up here, 15. And then just like our ratios before, if they can reduce, go ahead and reduce them. So it'd be 4 over 5. And apparently my screen really doesn't want you guys to see that answer. Okay, so 4 over 5. Maybe I could minimize this guy. Oh, whoa, it got real big there. Calm down. Don't panic. All right, that's a little better. I can still use my calculator. We're good to go. All right, our next one is cosine. Cosine is the ka version. So katoa. So looking at our cosine, it says find the cosine of angle K. Okay, angle K is over here. Identify that hypotenuse first, make our life a little easier. Okay, hypotenuse. And then like I said, if you know that the hypotenuse and the adjacent side both touch, let's go ahead and just say that this is the touching part, which makes that the ADJ. And finish up with the side that's remaining, the side that is opposite of our given angle, and that is 6. Let's see if I can get my box to come down here. Okay, so sine was so. Cosine is ka, like a bird. Okay, so cosine of K is the adjacent side over the hypotenuse. So cosine of K is 8, the adjacent, over the hypotenuse 10. And then since 8 over 10 can be reduced, we're going to reduce it to 4 over 5. All right. Find the cosine of D. So D is X. We can always identify our hypotenuse first because it's not going to move. It's going to be in the right spot, sitting right across from the box. And then the side next to the X, that's not the hypotenuse, is adjacent. Oh no, we don't know it. And then the side across from the X, not touching our given angle, is our opposite side. So of course we need to find A. So we got to go our homie Pythagoras. Old Pythagoras is going to hook us up. A squared plus 14 squared equals 50 squared. This number is going to get real big on me real fast. Mental math extraordinaire. 196 is 2500. I'm pretty sure I know this Pythagorean triple, but let me just verify with math. Okay, a squared is 2304. And then we square root both sides. Yep, just like I thought. Square root both sides. So A is 48. Now that we've got all of our sides, we can go ahead and use our trig to find the ratio of cosine of D. So remember, as cosine is adjacent over hypotenuse, so sine, ha, cosine. So cosine of angle D is the adjacent side over the hypotenuse. So cosine of D is 48 over 50. And then if it can reduce, we're going to go ahead and reduce it. And there's that Pythagorean triple we're used to seeing, 24 over 25. Okay. Moving on to tangent. Okay, so tangent, we're taking the hypotenuse out of it. Okay, we're taking the hypotenuse out. Tangent, TOA, okay, TOA is opposite side over adjacent side. So tangent is really the comparison of y to x when you guys get to pre-calc. Identify our hypotenuse first, because it's always going to be the same. Nothing's going to move. This one, they want me to find the tan of t. If 20 is the side that t is touching and it's a hypotenuse, the other side t is touching must be adjacent, which means across from t is our opposite side. So tangent is opposite over adjacent, TOA, so opposite over hypotenuse for sine, CA, adjacent over hypotenuse for cosine, TOA, opposite over adjacent for tangent. So tan T is opposite side over adjacent side. Tan T is opposite 12 over adjacent 16, which reduces to 3 over 4. All right. I'm just going to go ahead and pop this 14 in here because we found it on the last one. If you did not remember it on the cosine problem, remember that we've got the Pythagorean theorem at our disposal. So it says find the tangent of A. So this is A up here in the corner. Across from our right angle is always going to be the hypotenuse. Go ahead and identify that first. If we're in that habit, it helps us with the Pythagorean theorem. It helps us with our special rights. It's going to help us with our trig. The side that's next to it, that's not the hypotenuse, is the adjacent. And the side that's across from it, the side that it's not touching, is our opposite. So tangent is TOA, TAOO over A. So tangent of A is the opposite side over the adjacent side. Tan of A is 14 over 48. And that can reduce to 7 over 24. Now, you're like, Coach, what are these random things you're teaching me? Like, what are all these even mean? What is the tangent of 7 over 24 realistically even doing? Okay. Well, what it's doing is it's finding side links and you didn't even know it. The ratio of our trig function is finding side lengths. Now, this is just for the sake of knowing what's going on. So if you take your standard XY graph, the thing I was talking about earlier is this fella. This is called a unit circle. In my case, it's a unit oval. The unit circle is just showing you. So if this was my angle, say it was at 48 degrees, how could you find the length of that line? Now, this is where you're going to get real mad at me real fast. If we were to just drop this down, look what we created. We created a right triangle. So what we're doing is we're finding the length of lines. We're finding the ratio of where this exists. Not going to go too deep in it, but if you wanted to know the why behind what we're doing, that's the why. Okay, so this is where your calculator is going to come into play. We're going to find the side lengths using our trig ratios. So looking at number 7, we can't use the Pythagorean theorem because we only know one side. We can't use our special right triangles because there's no such thing as a 40, 50, 90 special right triangle. That is where trig comes into play. So we're going to look at our given angle and we're going to identify what sides we have. So looking at our given angle of 50, for 50, 20 is adjacent. It's the one next to it, but it's not the hypotenuse. And x is our opposite. It's across from it, not touching it, definitely not the hypotenuse because it's not across from the 90. Look at the first 2 letters of the sides we just identified. O and A. That's where SOHCAHTOA is going to come into play. Let me see if I can get this guy back over here. So remember that little mnemonic device I told you. So, O over H, Ka, A over H, and TOA, O over A. Looking at the 2 sides that is given to us, we are going to use tangent. We are going to use tangent. So we're going to take tangent of the angle. So tangent of 50 equals opposite side over adjacent side. So tangent of 50 is opposite x over adjacent 20. Now, this is what we've been doing for the last, I don't know, 3 weeks, 4 weeks, solving proportions. What helps a lot of kids is they don't realize that this 50 is kind of understood to be over a 1. Now you can see your proportion. So what we're going to do is we're going to take the tangent of 50 and we're going to cross multiply it to 20. And then we're going to take our x and cross multiply it to the 1. Here's how I want you to write it every time because you can't mess it up in your calculator if you write it this way. So 20, excuse me, x equals, okay, 20 times the tangent of 50. I know you're like, what? Tangent of 50 is a length. It's a value. So here we go in our calculators. Mine will turn on. Oh, maybe not. There it is. Batteries are low. You know, tough day. So we're going to go 20 times, and then we're going to hit the tangent button and 50. Close parentheses. Enter. And then if you're in degree mode, you should get a normal number. If you're not in degree mode, you may get something really, really small, really, really big. You might even end up with a negative. So just make sure you're in degree mode. So x rounded to the nearest tenth is approximately 23.8. So that's our side length. That's the length of x. Going to do it again over here. Find the value of x, okay? Write our trig functions at the top. So, SOHCAHTOA. Looking at the angle they gave us, the angle they gave us is 24. In relation to 24, we have x, which is the adjacent side, and we have 26. 26 is across from the hypotenuse, making it our hypotenuse. Across the 90, making our hypotenuse. So again, look at the first letters. We have H, we have A in our SOHCAHTOA. That is cosine. So cosine of angle 24 is equal to the adjacent side over the hypotenuse. You do not have to continue to write that out if you don't want to, but early, it's a good habit to be in. So 24 is x over 26. And then we're going to cross multiply. Do not forget that cosine of 24 is its own thing. It can't be separated. We're not just going to multiply by 24 and leave the cosine behind. We're going to take cosine of 24, multiply it by our 26, and then we're going to go x times the understood 1. So x equals, we're going to put the number in front of the trig function. So 26 times the cosine of 24, because it's its own thing, it can't be separated. Right to our calculator, 26 times cosine, the middle button, of 24, close parentheses. And x is approximately 23.8. Well, that's kind of a fun fact, huh? Find SE, so that's SE down here. Okay. Identify what we have. We have the hypotenuse because it's across from the 90. And then we have the side that's across from our given angle. So that makes it opposite. Okay. So, TOA. Identify what we have. I've got an O and I've got an H. So we are using, take that out of pencil. We are using sine. Sine of 42 is the opposite side over the hypotenuse. Sine of 42 is 12 over x. So it's a little different now. When we cross multiply, remember this cannot be separated. It's one thing. It's its own number. It's like saying radical 42. We wouldn't just multiply by 42. We end up with x times the sine of 42 equals 12. We're solving for x, so all we're going to do is we're going to divide both sides by this number. We're going to divide both sides by the sine of 42. Sine of 42, which cancels it out over here. And then we get x is approximately, right to our calculators, 12 divided by the sine of 42. Enter. 17.9. Thankfully, it wasn't 23.8. I was confusing myself a little bit. Okay. Couple more problems. Okay. Find AB, that's x again. Identify what they give us based on the problem. So 37. Whoops, let's not do that craziness. 37, we have 48, which is adjacent. And then across from the 90 is the hypotenuse. So looking at our trig functions we have, so ka, toa, identify the letters we know. We know A and we know H, which means we're going with cosine. Okay, so cosine of our angle 37 is the adjacent 48 over the hypotenuse x. Zoom in here so you guys can see what's happening. 37, cosine of 37 cannot be separated. Cross multiply. X times the cosine of 37 is 48. Divide both sides by the cosine of 37. That's going to cancel, or that's going to reduce to 1 on the left. X is approximately, right to our calculator, 48 divided by the cosine of 37. 60.1. Now, of course, we can use application problems with this. We're going to do one of these. Okay. An airplane. Everybody's been on an airplane. So we got our little airplane down here, just chilling. Don't make fun of my terrible artwork. That's a pretty good airplane. Okay. My airplane, if this is the runway, right? This is the ground. Okay. It's going to climb at an angle. So from the ground to the sky, it's going to climb at an angle of 14 degrees. Find the horizontal distance. So that's this number on the bottom. So that's x. It has traveled once it reaches 625 feet. So that would be somewhere up here. Over there. So identify what we have. In relation to 14, we have the opposite side. And we have the adjacent side, the one it's next to. There's a bell. Nice and pretty bell. So we're going to write our trig function. So, ka, toa. So we have opposite, we have adjacent, we have an O and an A, which means we're using tangent. So tangent of 14 is the opposite, 625, over the adjacent x. Cross multiply. Tangent of 14 is a number. It cannot be broken up. Cross multiply. So x times tan 14 is 625. Divide both sides by, t just went rogue on me, didn't it? Tangent of 14. Divide by the tangent of 14. So x is approximately 625 divided by tan 14. Enter 2,506.7 feet. So guys, that's the basics of trigonometry. We're going to go further to find out how to find angles and to find the entirety of a triangle. But what it boils down to is that. That is trig functions. So ka toa is the bulk of our trig functions. So you guys are rock stars. Thank you for your attention and have a great day.